in this particular scenario. And I know some of you already know what we're going to use, right? The quadratic formula. How many of you have heard of the quadratic formula? Yeah? Okay, so I know a lot of you have it memorized because you like it so much. But before I actually give you the formula that we'll use in this case, we have to just make sure we're all clear on what square roots are, you know, like what they mean and how we can use them. So let's step away from this. We'll come back to that problem, all right? So first, so put a question mark next to that, all right? We don't know how to deal with that. So now, radicals. Specifically, we're going to talk about square roots. So if I put this symbol, that's the square root symbol, and I put 4, what is that equal to? 2. Square root of 9 is 3. Square root of 16 is 4. So all it's asking you is to figure out whatever number's under here. You say, okay, what number that when I square it, I would get this. So 2, if I square that, I get 4. 3, if I square that, I get 9, right? 4, if I square it, I get 16. Make sense? But what about something like this? Square root of 8. So yeah, you can't come up, you're not going to be able to just tell me what number I square to get 8, right? Because it's not an integer. It's not a nice number again, right? But there is some number that I multiply times itself and I get 8. So on your calculator, you should have a key for this. So I need to make sure that everyone can find that key on their calculator and find what the square root of 8 is. And we're going to get a decimal answer. 2.83? Yes? I'm going to put those squiggly equals 2.83. Now the squiggly equals means approximately. That means it's, you know, you might have more decimals there, but 2.83 will go with that. So now let's just check it. Take 2.83 and on your calculator square it. And you should have a square key on your calculator. I believe on, let me just look over here. Yeah, you have a square key on there? No. You can use, on the calculator you're supposed to have for this class, you can use this key, it's called the caret key, and then put 2. And that will square whatever you put here. So just verify that when you do 2.83 squared, you should get something really close to 8. What are you getting? What did you get? 8.00? Something? Like 9 something? Okay, so it's close, isn't it? That's why this is a squiggly equals. All right? Now, there are some other ways you can deal with this. I know some of you already have mentioned this. I could hear you say it just now. That you can break this square root of 8 down to be square root of 4 times 2, because 4 times 2 is 8. And then you can break that down to be square root of 4 times square root of 2. There's a property of roots that says you can split them apart. And then what is the square root of 4? 2, and then times root 2. And you can't break down root 2 anymore. So this right here is actually what we call the exact answer. And this is what we call the approximate answer. I'm fine with approximate answers in here, mostly because of what we're going to be doing with this in a little while. The approximate answer is fine. If you want to give me the exact answer, go for it. I don't care. All right? Questions? What's the square root of negative 4? 2 pi? 2i. What the hell's I? Imaginary number, yes. So this is where we start to get into this weird place. I know some of you have seen this before, all right? The I thing. Now, in graduate school, I spent most of my time studying, like my thesis and stuff was dealing with imaginary numbers. It's actually called complex variables. And it's a whole new world, okay? It's a whole new world in mathematics. But let me just say one thing about it, because we're not going to deal with it, all right? Let me just say one thing about it. Come back to my art class here. There's a fish in a fishbowl, right? That fish is, maybe that fishbowl is on some table in your house, right? There's a table. Then over here in a different room, you've got, you're really going to like this. You've got your dog slash fox, whatever you want it to be, right? Do you think that your fish has any idea about the existence of this dog running around your house? Do you think it has any idea that there are trees outside? Right? I mean, like this fish in this fish bowl has an isolated universe, right? Its universe is that bowl. And it really knows nothing else outside of that. That doesn't mean that the dog doesn't exist and the tree doesn't exist, right? To the fish, makes no sense. So, the numbers that you deal with in mathematics, your whole life, these numbers, 2, square root of 8, 2.83, all the numbers that you ever deal with, 1/2, okay? Those are all what we call real numbers. And those numbers are fine, okay? In some universe, in the universe that you deal with your whole life, pretty much in math, you deal with real numbers. All I'm going to tell you is this. The imaginary numbers are like the dog. They exist, okay? Just because your universe has always been the real numbers does not mean that the imaginary numbers don't exist. The problem with the imaginary numbers is that when they were first talked about, people thought that the people talking about it were crazy. And like, okay, you're imaginary, like these numbers that don't, you know, like they actually thought like this was a joke, you know? Later on, it was proven that these numbers are just as real as these are. So it's kind of like in the beginning, they're like talking about, you know, yeah, there's these flying pigs, that, you know, pink flying pigs or flying elephants that exist. And people are like, yeah, right, whatever. You know, like get off whatever you're taking. And then it found out later, oh, wow, there really are flying pigs, you know, like, okay, so that's all I'm going to say about it, all right, is that I don't want you to go on with your life ever and think that imaginary numbers are just some made-up math that doesn't make sense. It is very useful. It's used all the time, and we can solve very complicated problems using the larger universe, the fishbowl with the dog. If we bring it all together, we can do some really good stuff, like put men on the moon and satellites in space and all that sort of cool stuff. So let you use your cell phones all the time, communicate with everyone, and it all requires advanced math. Okay, we're ready for the quadratic formula. Okay, so let me put it up here first. To solve any equation of the form ax squared plus bx plus c equals 0. So that should look familiar to us. Just on the side here, I'll just put an example. What was that example we had a second ago that we stopped on? It was like 2x squared minus 8x plus 1 equals 0. So as an example, this would qualify for what I'm about to talk about, right? What would A be for us here? A would be 2. What would B be? Negative 8. Don't forget the sign, negative 8. And then what would C be? 1, okay? So if we have an equation that looks like this, which we do, to solve any equation of this form, the solutions, I'll put solutions slash solutions, meaning you could have one answer or two, it just depends. The solutions are, and this is what's great about this formula. It's like, it's not telling you you need to factor, it's not telling you you need to do anything else, it's just going to spit the answer out. That's all it's going to do. It's just going to give you the result. The answers are x equals negative b plus or minus the square root of b squared minus 4 times a times c. This is multiplication. 4ac is 4 times a times c. The entire thing, everything up there, divided by 2 times a. All right, now how many of you have seen that formula before? Yes? Okay. So what we're going to do now is we are going to take that problem, we're going to use the formula, right? And we're going to get the answers, and then I'm actually going to do something hopefully you've never seen before. We'll see. But you have to trust me right now that this is true, that there is a quadratic, there is a formula that will give you the solutions to this, anything that looks like that, by just plugging in the numbers into that. So let's do it. For this problem, x equals, okay, first of all, we have to put negative b, right? So for us, b is already negative. So what happens when I do a negative with a negative? It becomes plus. So this is going to be 8 plus or minus. Remember we said we could have one answer or two? Well, this right here is going to give us the two answers. It's going to be a positive or a negative. We're going to have to check them both. Then we do square root. Now, this is one of the spots that students mess up quite a bit. B squared. Won't this always be positive? When you square a number, you get positive answer, right? So even though this is negative 8, when I square it, it's going to be positive 64, right? Okay, so that's what goes here, positive 64, minus, now, 4. So I'm right here. Now I need to multiply a times c, don't I? So I'm going to write this down. A is 2, so I'm going to put 2 here. And then c is 1, like that. 4 times 2 times 1. Then all of this divided by 2 times a, and a was 2. So in math, we call this type of thing a plug and chug. You're plugging in stuff and just chugging out the answer. Okay, there's no like real factoring. We have to come up with numbers. No, this is just plug things in and then work out the solution. All right, let's take care of this. This by far is the spot that people mess up the most, right here. Right there. They always seem to mess the signs up in this. So here's what I recommend you do. Just imagine that what I boxed there, right after the minus sign, just figure out what those three numbers multiplied together are. 4 times 2 times 1. And what is that? 8, right? Positive 8. Then we're going to put the 64 minus in front of it. So I'm going to write equals 8 plus or minus square root. Here comes 64, and then I write the minus, and then we got 8. Then all of this divided by 4. You do not try and divide 4 into these right now. No, 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 no. Don't. This 4 is going to be the last thing we do. All right? So I'm going to do 64 minus 8 right now, which is 56. 8 plus or minus root 56 over 4 still. And now we've hit a critical point. Is 56 a perfect square? In other words, do you know a number that when you square it, you get 56? No, right? It's not one of the common ones. So calculator time. You're just going to get your calculator out, and we're going to get an approximate answer here. So this is going to be 8 plus or minus. Now you do square root of 56 on your calculator. 7 point something? 7.48. Let's just go 2 decimal places. That's fine. You don't have to go any further than that. Notice the square root's gone, right? That's another mistake students make. They take the square root in their calculator, then they write square root again. For some reason, they just forget that they already took the square root. So just be careful. You already took the square root, and then over 4. So we're almost there. We're going to have 2 answers here. So here's how I like to do this. I like to do this and draw a little arrow up and an arrow down. This is me taking the plus and doing the math, and then this one's going to be me taking the minus. So if I treat this as a plus, we go 8 plus 7.48, and then divide that by 4. If I do it with the minus, it's 8 minus 7.48, and then divide that by 4. Order of operations. You have to do everything up here first. So I need someone, please add these two together. 15.48, oops, 0.48. And then divide that by 4. And then this one right here is going to be 0.52 divided by 4. So we only have one more step, and that's to divide each of these by 4. So somebody give me this one to 2 decimal places. 3.87 approximately. And this one right here, 0.12. 0.127, 0.12, 0.13, whatever. It's close enough, okay? We're not trying to land a man on the moon today. We can round and be happy. Okay, I'm not going to take off. If you put that 0.13, I'm not going to be like, haha, you're wrong. Okay? What I'm more interested in seeing is the work. Okay? Because if you go back and you remember, I think we talked about this at the very beginning of the class. I mean, the idea of you being in this class is not because someday you're going to need to solve a quadratic equation. It's because you need to be able to like follow a process, follow a procedure, and have your mind organize things in steps. That's what this is all about. If you have trouble retaining that, I mean, that's part of what we're trying to help you do, all right, is train yourself to be better at that. All right, so that means that if I plug in 3.87 right here and work it out, I should get 0. Now, it'll be approximately 0 because we rounded and stuff, but if I plug in 0.12, that'll work also, all right? You all good? Okay. Now, believe it or not, that means that this does break down, right? It does break down. And since these are two answers, you don't need to write this down, just want you to think about this. What's that all about? Come back to me. Okay, there we go. It means that this breaks down to be this. Okay, right? Because if I plug in 3.87 to this becomes 0. If I plug in 0.12, this becomes 0. But you can see right now that if I multiply this out, I would not get 2x squared, would I? So if that 2 would have to be out here. It's like a GCF we would have had to have pulled first. So if you pull that GCF, then that would have factored. But there's no way you're ever would have ever been able to come up with those two numbers, right? Out of your head. No way. All right, so this is a pretty nice formula, right? Because it just gets you straight to the answers. All right, what was the last problem that I gave us? That had x squared in it when we were doing factoring. Let me go back. Let me just pull one here. Did we do 6x squared minus x equals 15? I think we did. Did we do this problem? No? No, that doesn't look familiar now. What did we do? Oh, that was from the homework. I apologize. We did 2x squared plus 5 equals 2 minus 7x. Correct me if I'm wrong. It's like the second problem we did today. Yes? 2x squared plus 5 equals 2 minus 7x. Now, we moved things around and we got this. We were at this point right here, weren't we? We got to this. And then we did factoring, didn't we? What this is saying is that you didn't have to do factoring, that you could just use this formula. So let's verify that we would have got the same answer. So according to this, what's A? What's A in this quadratic equation here? 2, B is 7, and C is 3. So if I move very quickly here, I'm going to have negative 7 plus or minus the square root of 49 minus 4 times A times C, all divided by 2 times A. Okay, so that's what would happen if I just plugged all those numbers in. I'm doing this quickly because I'm just showing you that we're going to get the same answers. What were the answers we got, by the way, for that problem from earlier? Negative 1/2 and negative 3? Okay, so let's see if we get the same answers. This should be negative 7 plus or minus the square root of 49, and then minus, what are these three numbers multiplied together? What is it, 24? 24 goes here, all over 4. What's 49 minus 24? 25. So this becomes negative 7 plus or minus the square root of 25 over 4. And the square root of 25 is a perfect square, isn't it? It's 5. So this becomes negative 7 plus or minus 5 over 4. And now I can take my two different scenarios, plus and minus. So what happens if you add these? What's negative 7 plus 5? Negative 2 over 4, which is negative 1/2. What happens if you subtract? So negative 7 minus 5 Negative 12 over 4, which is negative 3. Same answers. You'll see that? So which way do you prefer to do it? It's really up to you. I mean, you could argue that, you know, if you're really good at factoring, the factoring, I think there's less room for error, but, you know, the great thing about the quadratic formula is that right there. It works for any quadratic, any. So if your factoring breaks down, you always have this to turn back to, all right? Okay, I didn't realize it was 12:24. Y'all ready for a break? Okay, let's go. We'll be back here at 12:35.
How I can change this from, because on my handler, if I do like square root of 56, it doesn't give me the decimal.
Yes. Okay, so there's a button here. Where is it?
I never did done a decimal before. I don't know how to do this.
Yeah. Is this it? No, no, no. Where is it? There it is. Ooh, whoa, oops. Okay, not table. You have to hit the green button first. So let me do square root.
Oh, okay.
So there's square root of 5 is that, right? And then if you hit green, fraction to decimal. Oh, no. Why did that not do that?
Is it for the square root? I think you have to turn it into a percent and then turn it into a decimal.
Maybe it's because it's irrational. Let me see what happens here if I do square root 5. What if I do times 1.0? Yeah, but that doesn't seem that efficient. See, if I multiply by 1.0, it automatically says, hey, now I want decimals. That'll work, but I thought there was a button that went straight to it on here.
Go straight through it.
Let's see, mode, normal, float, math print. No, you want to stick with math print.
Because earlier when you were doing and you went into the decimals, I wasn't able to do that. I went into like the exact.
Mm-hmm.
So mine didn't break down the way yours broke down. So I wasn't sure if my answer was going to be correct.
No.
Because I still had a square root of my answer.
Yeah.
You know.
Man, where is it? Let me see. Clearing, editing. No. I'll look into it.
Okay.
For now, just after you get that, do times 1.0.
Okay.
Or I think you could even do square root of 5.0.
Okay.
Yeah.
That'll give me the.
Yeah. So if you put a decimal 0.0, it's going to say, all right, decimals from here on out.
Okay.
But there should be a key. I'll look into it.
You know who Mr. Gonzalez is? The math teacher?
Yes, uh-huh.
How is he a good teacher or is he
What are you taking them for?
14? I started like a week.
Okay, so you're gonna do the 14, 14? Good. Yeah, I mean, he's been here for a long time. I mean,
Yeah,
he's,
I was just looking over like this, because I guess his class opened up, I guess,
Mhm.
for review. He has like a pre-test, and it's like,
oh, every 14, 14 has
Oh,
that.
that's-
Yeah, it's not just him. It's coming in, the issue that we run into is students are just not ready for it. So that test to just kind of say, okay, here's where we expect you are right now. Like this, solving quadratic equation, you should be able to do that already, like no problem. Here, the expectation is lower. So we're just gonna make sure students are ready. And if they're not, then there's other classes they can take. Not this one, but there's some other ones that will prepare you for that class. Yeah, so I wouldn't, yeah. Yes,
Question about the grading.
okay.
I wasn't really sure like how to type that.
Okay, so one,
And I had a question.
4.
about that as well.
So 4, this was right. So you missed 4 points. There. Okay, let me get my key. Ooh, yeah, that back looks right. From what I remember. So that was there. I mean, I should have given you points for that. 4.
I wasn't sure if it was already included because.
No, it's not.
Okay.
It's not. Yeah, you should, let me see, this should be +5 here. So, and it was only 4 off. Yeah, these other 2 are correct, if I'm not mistaken.
And I saw my problem here. I had the right thing, but I put it 4 over 4
Yeah,
for some reason.
yeah.
I don't know why I did.
Yeah. Well, hold on 17, now your slope should be negative. Hold on. Oh yeah, no, yeah. It's positive, so your line should slope like this.
Okay.
That's the only issue you have there.
Oh, I see.
It's a positive slope, but if you're, yeah, that's negative slope, right? That's positive slope. So this should be changed. I want you to keep this, so let me see, I can't get to it here. Let me see if I can get to it from my phone. Just hang tight. Yeah, time is it? 31, yeah.
You were divided 43.
Canvas teacher. I think I can change your grades from here.
Because I was,
Yeah,
when I
and
saw
then
the
just
graph and it's at 105, it's like, oh, it's not added. But then I didn't know it was a bonus question.
What?
That's what I was thinking too. I didn't get confused with keeping this one.
Why wouldn't it
So you can-
let me do that?
Oh, okay. Oh, like you said, I was this one.
So it was -4 and then +5, so.
It's because I have the notes. I was writing down a lot of the notes.
So I was like the first one.
Because I go to that. Oh, I didn't, did you get them to work?
Okay, you'll just want to double check online to make sure that that went through, okay?
Okay, these.
Thanks for pointing that out.
Oh my gosh. I did not. Oh,
Yes? Okay, good.
Right, like, because sometimes it's easier.
All right, y'all ready?
Yes.
All right, so I've been debating all morning whether or not I was going to show you this, but I'm going to show it to you. So, without offending anybody, you've heard the story of the Ten Commandments in like some like burning bush. Have you all heard that before? Okay, so there's a story like the Ten Commandments you're supposed to live by. Someone went up to a bush or something, and there was like tablets that had the commandments on them, right? If you've heard that story, right? Not saying that you have to believe in it. I'm just saying if that's a story, right? Well, I've heard a story that also, like on the back side of it, there was like all the mathematical equations that we needed, right? No? No? So where did this come from? I mean, the formula is very useful, right? Where to come from. So I'm going to show you, I'm going to derive it. I'm going to show you how to get to that formula. Now, this is not for everybody here, all right? I'm going to lose some of you, I think, but there are enough of you here that might appreciate this. Let me just start it with this. Remember, if you have an equation, you can always add anything you want to both sides or subtract anything you want from both sides. You can always divide both sides by something or multiply by something, as long as you don't multiply or divide by 0. All right? Do you all agree with that and believe that? Okay. All right, so here we go. I'm going to start off with the equation that we're trying to solve. And I'm not going to put numbers in it. I'm just going to leave everything A's, B's, and C's and X's, all right? So the first thing I'm going to do is I'm going to divide both sides by A, all right? And divide everything by A. Now, am I allowed to do that? Well, we're assuming A is a number that's not 0. Because if it were 0, this wouldn't be here, right? And then it wouldn't be quadratic anymore. So I'm going to divide everything by A. So if I divide this by A, what would I get? X squared. What would I get if I divided this by A? Bx over A. Is that all right if I write it like this? B over A times X. Is that all right? Same thing. And then plus C over A, right? And 0 divided by anything is still 0. So do you agree that that's still legitimate? I haven't broken any rules. This is good? Okay. The next step is going to look a little weird, but just all your job right now, all your job is to sit there and tell me whether or not what I'm doing is legitimate or not. Don't be so much sitting there going, well, why did you do that? All right? Because the answer to that question is that somebody spent a lot of time in their life trying to figure this out. And that's what mathematicians do, okay? They get problems and they try and figure them out, all right? Crumble up paper, throw it away, start over. Crumble up, throw it away. There's a lot of failing before they succeed, all right? So everything's still good here, all right? This one right here is kind of the crazy part. Let me see if I can remember what to do. Yeah. Okay, so now what I'm going to do is I'm going to introduce, you told me I was allowed to add anything I want to both sides, right? Okay, so I'm going to add to this, on this side of the equation, I'm going to add b squared over 4a squared times x squared. Don't ask why. Just, that's a number, right? Do you all agree? Not a number. This is something, right, that I'm adding to this side. And if I do it to that side, I have to do it to this side. So I've added the same thing to both sides of the equation. Yes? Wait, hold on. Oops. No. Take out the x squared. That doesn't matter. We can just do that. That's less, right? This, okay. All right. Now, that left side is now something very special. Now let me show you what it is, all right? Just hang tight on that. What if I took x plus b over 2a and multiplied it times itself? Let's see what we get. Okay, let's just see what we get here. If I took this and multiplied it times itself, then what would my first term be? X squared. Okay, what would my next term be? It would be b over 2a times x, right? What would the middle term be? Same thing, b over 2a times x. And then what would my last term be? So if I multiply this times this, so b times b is b squared, and then 2a times 2a is 4a squared, right? These two are like terms because they both have x in them. So what I would do is take b over 2a and add it to itself. They have the same denominator, don't they? So I just add up the numerators. What's b plus b? 2b over 2a, which is just b over a, right? So x squared plus b over a x, those two together, plus b squared over 4a squared. That right there is this, right? Okay, so that means this is this, right? And this times itself, I can rewrite that as x plus b over 2a squared equals this, right? That's this squared. Yeah, I'm sorry, there's something on the screen that's bothering me. Okay. So this side, this actually factors to be this. And then this side of the equation, all I'm going to do is switch the order. B squared over 4a squared minus c over a. Y'all still with me? Okay, now it's going to start to get kind of interesting. Now what I'm going to do is I'm going to get a common denominator between these two and put them together. So what happens if I try and get a common denominator here? What is this one missing? 4a? So I have to do it on top and bottom, right? Okay, so now do that. And since they have the same denominator, the denominator is going to be 4a squared. And what's the numerator? B squared minus 4ac. Does that look familiar? Have you seen that before? Have you seen that before? It's starting to come to life here. All right. Now, at this point, I'm going to take the square root on both sides of the equation. The reason I'm doing that is to kill the squared. So I'm going to take square root here and square root over here. And anytime we take the square root on both sides of an equation, we must do plus or minus. Now, I haven't talked about that too much. You're just going to have to more take that on faith at this point. So what happens when you square root a squared? It goes away, right? Kills this off, and all you're left with is x plus b over a. With me? Okay. This side, I have a square root, right? Now, when you have square roots with fractions inside of them like this, you're always allowed to split it up into two roots. You can do that. So what I'm going to do is I'm going to do the root on top and the root on the bottom. Okay? But what's the square root of this? So what's the square root of 4? 2. And what's the square root of a squared? A. So that's this, right? Y'all still there? Yeah. Okay. We're like 2 steps away. I'm going to move this to the other side. Hold on a second. Oh, sorry, I wrote this down wrong. Look, this is b over 2a. Sorry, this should have been 2a down here. That's 2a down here. Don't these already have the same denominator now? Yeah. Put them together, and what do you get? Negative b plus or minus square root b squared minus 4ac all over common denominator 2a. That's your quadratic formula. I've taken an equation, I have isolated x, right? I've found a way to isolate x by itself in terms of everything else. Yeah, someone suffered quite a bit to get that. What's that?
Who came up with that?
I don't know. I think it was found by various people, various cultures found it. It wasn't. I'll have to go back and research it. I'm not sure if any one person gets credit for it. So it's kind of interesting because there's a formula. If you change this to like a cubic equation, like let's say that's cubed and this is squared. Let's say you put c times x and then plus d. So in other words, if you take the equation up one notch, make it a cubed, squared, first power, and then no x's, then the question is there a formula for that? That would be called a cubic equation. And you could Google it. There is a cubic equation. It's pretty ugly. It's like half a page long. The formula is actually like half a page long. And then if you move this up to 4, there is an equation. It's like 2 pages long. It's ridiculous. And it's been proven that if this is 5 or higher, there is no equation. It doesn't exist. Which doesn't mean we haven't found it. It just means that when you prove something doesn't exist, that means it can't happen. Like you cannot have an equation for 5 and up. It's impossible. It's only for squared, cubed, and 4th degree. All right, there you go. We've derived the quadratic formula. And that's what we have to do for all our formulas in math. Someone has to suffer, and I mean suffer. Yeah. I'm going to read you a text. See if I can remember this guy's name. I have a former calculus student who's a math major, and he's now taking like his junior level math classes at a university. I'm just going to read you what he says. Oh, he just put, I don't know how you did it. I love it, but studying math has shown me true suffering. That's what he put. So when I say suffering, I mean like mental suffering. That's the math field. But it's good. You know how you get that feeling when you get something right in a class like this? You know, you're struggling maybe with a concept and you get it right, and you're like, wow, it makes you feel good, right? It's always good when you get it. It sucks when you don't. And math is like that the whole way through. It's just that the getting it wrong becomes more, and you have small bits of reward when you finally get it. But those little times that it happens, it's a great reward. All right, quadratic equations. You have to practice with that formula. There's no way I can sit here and I can put problem after problem up on the board, and I can show you the math, and I'm not going to get it wrong. I mean, I could make a mistake, but I'm not going to make the types of mistakes that you will make, because it's just natural. If you're using this, you don't use it on a regular basis, you're going to make mistakes, right? So what I think we should do right now is have you practice some problems using that formula, all right? So it's 12:50. Let me put up a couple of problems up here for you. So I want you to solve these using quadratic formula that we just derived. Wow, that's amazing. So here it is. It's up on the board for you, okay, if you need it. Let's see here. X squared plus 12x equals 9. That'll be the first one. Second one, let's go with x squared plus 4x plus 17 equals 8 minus 2x. By the way, as you're working these problems out, if you're ever using the formula over there, and underneath that square root, if you ever get a negative number under here, you're going to write no real solution, and you're done. Okay? No real solution. That's what you'll write. If you get a negative underneath this root, that's what you do. That's the fishbowl saying, I don't know what a dog is, I'm done, right? Okay. I want to see how you handle this one. And the fourth and final one, let's put one in here with a decimal. All right, there you go. So let's work on that. You can work together. I encourage you to help each other out. Make sure everyone at your table is getting the same answer. Or same answers, I should say plural. And we'll take, let's say, probably five minutes for each one. So maybe the next 20 minutes we'll do. No, you don't have to turn these in. I just want to make sure that if you're going to make any mistakes, I want to be able to come and help you so that at home you don't make the same mistakes. Practice using your calculator and everything else. Yes.
Just have a question about the other stuff.
Yeah. Hold on, I was going to do something, but I... Yeah, no, that's it.